Hello, everybody. We have another speaker today for the CSS seminar. Today we have Professor Lingfei Wu. He's an assistant professor at the University of Pittsburgh. He works in the area of science of team science and employs various computational tools, big data, AI, and has a very impressive publication record in general science journals from Nature, PNAS, PLOS1. And on top of that, he is an expert in data visualization. So I'm looking forward to seeing your slides and your talk today. So please welcome Dr. Lingfei Wu.
Hope you enjoy the food. I was trying to stay hungry, stay foolish. And I hope food is not too good, otherwise we just get coma. So I'm here to talk about perhaps arguably one of the most important things in our life in the past 3 years, right? The impact of COVID on our life, well, as a knowledge producer, right? So for now, it's just an assumption, kind of a slogan, a vision, a motivation. But I'll just we'll walk through this thing together and unfold the topic of whether how does remote teams affect the process of idea generation, right? Maybe a good place is to start is to think about how things has changed in the past 50 years, right? So this is what lab meeting looks like in 50s. And this is literally two person at our age, or maybe your age, that changed the history of biology, right? This is Watson and Crick, when they were discussing about envisioning the three, the helix structure of the how life, well, the material that life used to reproduce itself, right? And this is a little lab meeting nowadays. I'm not saying it's not fancy or not interesting or not diverse enough, but you do feel the vibe. You do feel the vibe that we have more people include. We try to make everyone speak, but it's very infrequent that you can always have everyone express substantially what they were thinking about and all that. There's some subtle change when you switch from offline like this, right? When we all together get stuck in the room and you have to listen to me for the next 1 hour, instead of we just get online and you are opening multiple tabs, right? And you can control your attention between one task and many others, right? So this naturally raises the question, how innovation at distance happen? Or particularly, can remote teams innovate? Well, we better hope it is, right? Because if it's not, or anything like negative, then we have a big problem to deal with, right? Okay, so before we proceed with that, 1 minute introduction about myself. I got a communication degree in PhD in the City University of Hong Kong. And in my first postdoc, I worked with physicists, published on physical journals at the ASU Santa Fe Joint Institute. There was a lot of good physicists over there. We were searching the general patterns of human behavior and the laws. And then my second postdoc was done in Chicago, sociology. There are a lot of great minds there talking about theories. So this fills up the very interdisciplinary background. And now I'm working at the University of Pittsburgh, and with a focus of science of team science. But back to our topic today. We want to know the impact of remote teams on innovation. But first of all, we need to solve these lonely debates, fundamental issues in science, technology, and everywhere, right? How to measure innovation? Well, everyone has their own ideas of how to measure it. But one interesting thing is we see a lot of great minds, or may I say the best minds in history of science. They notice this tension, this dichotomy between two efforts, right? One kind you can call it like exploration versus exploitation following the James March approach, you can call it subversion versus secession. If you're a big fan of the philosopher Bourdieu, right? Or you can call it originality, relevance, decent, conversion. It doesn't matter how you call it. All these great minds notice these two fundamentally difference in contribution, right? In how science and technology unfold itself, right? So that really built up our last work, which was likely to select as a cover in the Nature on 2019 in the second month, right? It's a spring and it's widely reported by general media, all these top outlets. Now, the intuition behind that measure, what we call disruption, is quite straightforward. So basically, you have, this is your work, right? And your work will have some kind of impact, hopefully, that's fingers crossed, okay? But once you have impact, you can identify two kinds of impact. These are the future papers that cite you, but not your reference, okay? They kind of acknowledge that this work is important enough and innovative enough, it doesn't need to go back to your intellectual forebears, right? And these are the work that cite both you and your reference. They are like kind of voting for the relevance instead of the originality of your work, right? So now, and the K is just other works that cite original work that you also cite, okay? So the intuition behind this measure is you just identify these two kinds of future followers, two kinds of fans, right? If all your fans vote for your originality, they win the game and you are quite original, right? And otherwise, if all your fans vote for the relevance, then it's very developing, right? And if you have no fans, well, like most of us, but then you're screwed, right? Okay, so this is how the measure was constructed, and we do extensively verification of the measure. You know, it's so easy to come up with a measure that if you go to these kind of journals, I'm not going to name the title, but you see like every day there are new measures come out, right? But the key question at this step is, does that actually measure the thing we want to measure, right? So we want to unfold all these tons of details with just one case, right? So this is one of my favorite paper in physics. I have some among all scientists. So it's called the Sampire model, right? That really, it's like three guys in physics and propose this this is a toy model, and that really opens the new concept of self-organized creativity, right? It becomes part of the entire string booming field of complex systems. So that's quite innovative and foundational. Now, another work published on similar years on the same journal physical review letters, and definitely of the similar amount of importance, or maybe more important, that's Davis and his team's work on first observation of Einstein-Bohr's condensed matter theory in the lab. Okay, so they are verifying Einstein's theory, and for that they got the Nobel Prize. Well, sorry for this guy, they didn't, Nobel Prize love this empirical work, but so you cannot say Davis' work is not important. But you definitely see, although they have very similar amount of citation impact, which just dominate our business of evaluation, research evaluation today, right? It doesn't, that citation impact doesn't distinguish these two kind of efforts or contributions of highly disruptive work versus highly developing work, right? So if at this point you're still like, what? I get what you're saying, but can you give me a picture of what disruption really measures so I can see it, like how you see it, right? So this is a picture. This is a picture. A disruptive idea, reinvent history, eclipse the past. So it's like what happens in eclipse, right? All this great work in the history, they are so great, they are so shiny, but they are also so far from you, right? As time unfolds, the universe of knowledge expands exponentially. Now to get to you, to get to our generation, you need to be super disruptive. And if you are super disruptive, you just eclipse all the things past. You're like, it's a statement that history starts from today, from my work. You don't need to look at back of all the past work, right? I already successfully summarized and integrate them, right? So in following this intuition, it's time to do a little bit art when you are so bored in, like me, in 3 years of the exploration. So we talk about this work, we talk about these 2 examples, and I do a little bit art to visualize how different work unfold itself, right? So every single work is placed here. This is a focal work. We talk about the citation network and how they look like differently, but to visually, I use the metaphor, I borrow a metaphor of a tree, right? Every work is a tree that cite the past and impact the future, right? So this is how the time unfolds itself, right? So this is how history unfolds itself. You cite some kind of work and you generate impact into the past. So there are 2 kinds of future that you generate. A future that every paper cited, you also cite a reference. I call that gravity towards the past, right? So they are kind of bowing down, looking past to your roots, right? And another kind of future that you generate is every work cited, you know your past, right? Know your reference. So it's kind of, I make it curve up and make it green, right? Okay, this is the design. And in this way, we can see how these 2 trees, the 2 most important work in physics, look so differently, right? This is fundamentally differently. And you can just play around with that and see how different work, they are all important, but demonstrate very different shape and forms because they were designed a different purpose and gift and inspiration, right? Okay, now time to do some real science. This was inspirations, measure design, and we haven't talked anything about like mechanisms or associations or insights, right? So big data. I believe all people in this room are talking about use program a lot today and use a lot of data. So we'll just skip the details. In sum, we got 65 million teams, and we associate team size with the disruption percentile, right? So a very fundamental finding is small and large teams, they think and act differently. It's not additional. You usually think, oh, I will just input one more person, one more, like extending my lab as I'm so it doesn't work in that way, right? When you have a small team, they're highly disruptive, but the chance they have a lot of attention, citation is very low, right? Versus if you go to very large teams, you grow your citation or your capability of harvest the immediate mature attention market at the cost of your disruption, right? So a way we look at all teams across 3 fields, across 65 million teamwork is quite robust. It's very robust, showing that these are 2 different kind of effort. One eclipse the past, reinvent history, while the other one is like broadcast the past. Think about Davis' Nobel Prize work, right? Basically just broadcast and confirm Einstein was right. Now go to Einstein, right? Instead of Einstein just eclipse Newton and say, yeah, I'm right, I'm the cool one. So very robust pattern with the increase of team sizes have decayed disruption across all time, space, places. Okay, now I hope you're halfway at your lunch and you have successfully buy my story of the measure of disruption. Right now now this is the moment we can still secretly replace a word here. We ask a new question: can remote teams disrupt? Right. And here, motivated by that question, we collect again our old tricks of big data, 20 million papers, 4 million patterns across all places, times, and countries. And this shows where our data come from. Our data covers in cities, in science, and this shows the pattern, right? Data. We find a quite substantial and striking trend that is happening in the past half century, right? The average collaboration distance is increasing dramatically For science, it's like from 100 kilometers to 1,000 kilometers, like 10 times larger. And for patterns, similar chain. But in compared to that, this remote collaboration around the globe, it's less impressive in terms of their contribution to disruptive innovation, right? All the way down. And now at this point, we can say it's like you have more remote teams, everyone is connect, everyone want to connect, right? But do they actually generate a lot of disruptive ideas? Maybe not, right? Now, the first response of me was similar like you. Can we believe in this? This is a correlation. Correlation is not causality, you know. Okay, now let's think about alternatives, right? Maybe it's about measure bias. You know, you just spend half an hour, 15 minutes talking about disruption, convince everyone disruption. Your last paper is useful, and now you're saying, yeah, it's useful for next paper. That's the business, right? Okay, what if we don't measure disruption? We measure the chance. Here's the chance that a new paper or a new pattern brings in a new scientific concept. So it's counter. It has nothing to do with the citation network structure or any bias related to the network measure, right? And the chance you bring in, you're inventing a new concept like criticality, critical self-organization, right? It's very low when you have a remote team, right? And the same thing for technology code for patterns, right? And okay, now it's not about the why. It's not about a depending variable. It's not about how you measure innovation. Maybe it's about how you measure distance, right? You measure distance in a way that favor local teams and disfavor remote teams. Now, we try all different kind of measures. Maybe we don't measure the average. You measure the max difference. Maybe you don't identify people. You don't identify city, right? How many cities cover? Maybe this, maybe that, maybe it's continuous, maybe that. It doesn't matter. It doesn't matter how you change X, how you change Y. The association, the negative one, it's quite robust. And it doesn't matter whether it's about small or large teams, because I just tell you the idea that large teams is less disruptive and small teams. Now, whatever, of course, right? Remote collaboration is large teams. You have to have more people. Maybe it's just because they are large, so they are less. No, even in control the team size, it's still less disruptive, right? It cannot be explained again by research fields. It's not the way, it's not the nature of knowledge that you are working on. You cannot blame because I'm doing computer science, so I'm doomed to be less or more disruptive. No, it's not irrelevant to that, right? Or you cannot blame your generation, right? Our generation is, you know, that low-hanging fruit story, right? They eat up all the great work, food, and we have to just do our little small thing there, just because my grandfather is so great, so they suck. No, this is irrelevant with different time period, right? Even in our generation or in last generation and the next generation, there are going to be this kind of difference. And finally, it's not a like selection bias, right? You're like, maybe there are some scientists, there are the individual difference between scientists. People who are more creative and more disruptive, they just don't like remote team. They anti-Zoom, right? So they only work in on-site teams and they form the group, and the other kind of less innovative brains, they just get together on-site teams and talk about things on Zoom every day. Maybe it's because of that. It's because of the difference of scientists, not the way they coordinate within teams. Well, we have excluded that too by using a technique in social studies called order fixed effect. So basically, the takeaway lesson is within the same order, the same person, when they act across different contexts of teams, they perform differently, right? And the same for the paper, the same for the patterns. Okay, the last strike or the tag, the question comes from a well-established theory in the innovations. It's called the burden of knowledge by one of my favorite scholars, Ben Jones. Right? So the story basically says that it's very innovation the science is accumulative, right? As science unfolds, you have more things to remember, and because you have more things to remember, you cannot remember them. That's called the burden of knowledge. Now, under this burden of knowledge, people will respond with a longer education time, with more narrow expertise and working in teams, right? And now the burden of knowledge happens to history across generations and happens to individual life of academic life, right? So over time, you are less likely to innovate. You basically protect the things you early on 20 years ago, right? So in one way, we agree with that. Yes, within individual career, you are getting less disruptive, but it doesn't explain. Because here's the question, right? If like on-site teams, because they're small, because they are local, they're all just junior scholars. And they're just like PhD students, and they just PhD students by definition of the burden of knowledge is more innovative, and they are going to innovate. And these remote teams always have like a lot of money going on, a lot of funding going on, a lot of big idea going on, big in terms of like impact. So these are like senior people. So maybe it's just the age difference, right? We control that again. That cannot be explained by this difference. It's the same career age, same young people, same old people. You still experience this kind of difference in on-site or remote team, right? Okay. Now this is the end. This is everything of my talk, and this is the time we confirm we have done our job, right? We have proposed a measure. We do the correlation. We rule out alternative explanations, and it's time to have a chef splash. Send out, right? Publish. But here's something I want to share today, right? With our, if we can consider this a community of computational social science. This kind of business ends is where our business starts, right? The next question that ends at the last stage, open the new stage is, can we open the black box of interaction within teams? Because so far we know large and small, remote and local, and other teams act and think differently. But teams, there's nothing called team. They're just a team of people. And we say that it's not about personal choice where you perform differently, but how do you perform differently in on-site and remote teams, right? So it's time to take off your jacket and dive in the real research, right? So here's where data science and AI, which is relevant to a lot of your business, starts. And here's where we are going to apply it in our research, right? So again, look at the data. We have tons of data, and it's such a waste and such a shame if we just send out a paper like what we had last stage, right? Why don't we use the power of the data and go to first? Can we separate space and time effects, right? Like we talk about distance, but what is distance? Distance has two potential interacting factors. Distance can be because we cannot talk to each other, right? And because we have different time zones. When you get up, I have to go sleep. So this is like time and the space separations are quite different and requires and demands very different policy remedies, right? So it's nice if we can separate them, and we did separate them. Within that, we separate groups into three, right? Local teams, remote teams, as oral business. But within local remote teams, we separate if they share the same time zone, only have different distance, or they have different time zones and difference, right? So in that way, we're kind of cutting this data into piece, and we know the additional effect every stage, right? And turns out the in-person interactions really, the lack of that kind of interaction really has played a role, even they are all the same time zone. So you cannot blame the difference in the working conflicts schedule in this case, right? Now, the second thing is, can we look at what people do in teams? That would be nice, right? Like, so one thing built upon our recent publication on PNAS, we collect data on these kind of things, right? That I just copy and paste the contribution text of our Nature paper, and it says who does what in teams, like who conceive the research, who design this, and who analyze data, and who produce all things, right? So in that way, you can identify the keywords, use a very simple 20 years ago, old-fashioned NLP technique, right? I think about how fancy this research could be if we use nowadays, right? Okay, so this is like 20 years ago, you just get the verbs, right? And clean the verbs and consider how they co-occurrence within the same order. If the same order who conceive the research also prepare the data, then there's a link, right? So across many these kind of individual orders, you can see there are actually role splitting, right? People who conceive, write, supervise, design, interpret, they don't collect, analyze, develop, conduct, right? There's two different kind of job going on here, right? And we do that, we use the ground truth data of 60,000 other contribution across these 4 journals, across 10 years, a substantial coverage of the time since they were required. And then we build a little neural network machine learning model to include all these features that are relevant. And with that neural network, we can project that to a big data of 60 million papers where people never say what they do in the teams. But now we have a theory, we have a prediction of what they actually do in teams. So to test the robustness separation of roles, right? And what we found here, based on all the data that we used, the prediction, and also the ground truth data, high precision, small amount, but very informative data, is that people actually do different things in different teams, right? That's the same author. We select the same author, is 20,000 each people. They are less likely to write and conceive. When they go online, they are more likely to perform and then analyze, right? Less likely to analyze even, just more likely to perform, right? So this brings up a little topic that I'm not going to unfold today. That is, we usually think knowledge production is just you do A, I do B, right? No, that's not that. It's not a simple labor division. It's a process, right? Someone got to come out with the idea, and someone got to do the experiment, evaluate, and come back to the idea, and do this loop again and again and again, and eventually write the paper, right? So there's a hidden circle of this scientific, of this knowledge production process, and there's hidden hierarchy. You got to be the brain at some point. Otherwise, it's very hard to imagine how your career in academia unfolds itself, right? So there's a hidden hierarchy here. You got to switch the roles. It's not like you do A and I do B, which is all happy, right? That's not a reality. And at this point, it's interesting to think of how does remote and on-site teams work to your career, right? Now, another thing we can do with the power of big data is to illustrate the direction of causality law, right? The flow of causality. Okay, I know I'm like in the deep water now. When you say causality, you open the box of the direction you don't want to go, right? So there are a lot of fancy ways to do causality. Like if you are smart and you are rich, how do you do this causality, right? You go to buy a book called the Book of Why, right? And you go through all the pages and you calculate all the things. But here's my stupid way of doing causality. Okay? This is a very low cost way of doing, you calculate nothing. Okay? Think about how causality is important in our research context. We just say, if you work in local and on-site teams, you may have different idea quality, right? Innovation. And people may say, no, it's quite the opposite. It's a reverse. You have the good idea first, and you go to on-site teams, you seek an on-site collaborator, and you have the boring idea, you want to develop something, you go remote, right? How do you know it's not a reverse? So one way to look at this is, what if we can fix the initial quality of the idea? This is fix it. No complex, no fancy, no expensive metrics. You just fix the idea. You were like, this is a running line, right? You start from the same idea and ask two teams to run and see who runs faster, right? Who advances the same idea faster. In that way, you cannot blame the unequal running line, starting line of the idea quality or innovative, right? And we actually do that a lot in science, right? All science papers, perhaps not all, but many of them starts from some grant proposal, right? That's why a lot of us are here, right? We got paid. Where does the money come from? NSF or IC or elsewhere, right? So you got to have an initial idea. The science business is happening nowadays in this way. You got to have an initial idea to do the work, right? Now, for me, it's very fun to read through how the many teams proposals different or not different from their published papers, right? I give the example here. Basically, people say, the proposed approach is blah, 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 is nearly impossible, blah, 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 blah. Here we go, right? They can see it, but they cannot do it. This is talking about some kind of new algorithm of a mobile device, right? The calculation. So basically try to infer where the users are using that little device that this person is proposing, okay? Now, after the person got the money, several years over, and the teams assembled and delivered the paper. Now you look at the paper. They cannot reproduce the behavior of users because things will, so they just cannot, they basically just rewrite the proposal, right? They basically just rewrite this narrative. And sometimes we even see examples, people don't rewrite their proposal. They just put the proposal abstract as a paper abstract and publish it, right? In this case, there's no idea in advance. You basically have the same idea, and then you go to test the idea, and then bring the idea back and publish it, right? You don't even want to edit it. Sometimes, for science paper, you edit a little bit, so it's not too much, right? So in this case, we compare how much idea is advanced from the proposal to the produced papers by remote teams and local teams, right? These are like visualization of 3 abstracts. These are actual words in every place. And these are the keywords they use to talk about the abstract, right? So we measure in 2 ways. One conventional way in entropy difference between the word, the frequency distribution. And the other way is a little bit fancy, use Cybird with, I would say state-of-art machine learning model in other universities, but not here. I know how fast things are moving here, right? So it's like several generations ago, but quite recent version of NLP models, right? And it doesn't matter how you measure it, remote teams always runs faster, right? Okay, so the last, one of the last things we want to do here, using the power of NLP tools is, what if we know what kind of knowledge people are actually contributing that relate to the separation we just discovered, right? On-site teams try to do more innovative work, advanced idea faster, and remote teams try to develop more, right? And this must relate to their contribution of reference, right? So we identify different functions of reference. Sometimes you cite things to support, to talk about the background, why I'm doing this research, how this research is relevant to previous research, and sometimes to compare, right? Of course, you got to relate, connect. And in many cases, you cite reference to support you, right? You use or extend or talk about in future you will use or extend. So in this way, we see a quite dramatic difference between on-site and remote teams in the way that on-site teams emphasize their theoretical contribution, right? How my research relate to the past. And remote teams stress their methodological contribution. Yeah, this I changed 1 parameter of that thing, right? This is quite different. And of course, we always need to give us a little break by doing music, right? So if you see these 6 different contributions from more conceptual theoretical to more methodological, is kind of a music, right? You can just visualize how they cite reference at different pitch, right? And in that way, you can pinpoint it. You say on-site teams kind of play the base of science, right? The more theoretical, foundational at every corner of science. The last slide I want to share here is this kind of large data also give us a chance to take a glimpse of future science that could quite impact by how we organize science today, right? So there are different futures. We just talk about people have different, people are more likely to do conceptual or theoretical contribution, blah, 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 in on-site teams, and people are less likely to do so. People more likely to do the technical work. It's quite a like brain and muscle separation, offensively defined here. But here's the question. Are all people the same, right? Are all people the same in this exclusive opportunity of conceive and be the brain? Maybe not. Maybe the roles of teams is relay to the impact, right? We all know the Matthew effect story. When you have more impact, you get more impact. But what about when you have more impact? What's your role in the teams, right? So driven by this curiosity, we analyze the chance of two workers both conceive the work in the team. And how does it depend or change with the citation impact difference, right? And in on-site teams, it's flat. Strikingly, we didn't manipulate anything, it's just flat. And it doesn't matter how many citation impact between you and the like junior scholar and the senior scholar, it's just the same thing, right? It doesn't change. But in remote teams, if you're junior, you're screwed, right? There's no chance you kind of equalize yourself and, you know, I have an idea. You don't have an idea. This is about the idea of the most impactful person in the team. And the team was assembled to build the idea, to develop the idea, to verify the idea, right? And you want to do that or you don't, right? So this is two fundamental dynamic displays by on-site and remote teams, and think about how this will shape future science, right? The general hierarchy difference between people already increased in the past decades, and now within teams is even more, right? So if we have everyone connect to everyone through online teams, science just be hierarchical, and science is all about celebrating the established scholars and no new ideas, right? So that's quite a good place to conclude this research and this little journey that remote teams do field fewer ideas. When people connect online, when people reach out to people from another country, in many cases, it's about celebrating and diffusing existing idea, right? And we should not, in the time of COVID, we should not, this kind of on-site interactions should not take the back seat of the construction of digital technologies, right? So, and a little big picture here is that I'm committing myself into is, I call it the science of team science innovation. You got tons of archive data here now, and you can just extract the patterns out of that and guide the policy and change the future of science, right? And this is quite important topic nowadays. The future of science seen from 1950s is very, very different from the future of science seen today, right? In 50s, this is Van Bush, who came up with the report that basically became the foundation of NSF and basically invent NSF and the government-driven science support mode after Second World War, right? And his generation is like, my grandpa's generation is like, cool, don't worry, kids. We'll send people to the moon, and they did it, and then we'll make science better, right? It's that kind of confidence. And this is my generation, right? This is one of my favorite information source, like very, very trustable. I look at it every day, right? You got your inspiration there. And this is what people discuss, right? It's the rate of science discovery slowing down, right? And this is my generation, like, has been 3 hours and nobody like my Facebook or Twitter, right? I post something. So we have very different mindset, right? But can it just be our vulnerability, our incapability? We have no ideas. Well, our grandparents are so great, they built a foundation, we just bite our ears. Or is actually a serious concern that been quantified nowadays. There is a rising voice among the scholars talking about the slowing down of scientific engine, right? All these great works talking about you have more papers, but not so for concepts, right? And the disruption and everything is slowing down. Maybe it's a time to think about, can science be reinvented after 50 years, right? Or if you cannot invent the science, you invent the way scientists organize. You cannot, if the whole US or any other country have 50 physics or computer science last year, it's not going to be 100 next year. That's how fast science grows, right? Science grows very slowly, but you can definitely change the way people connect together, right? But how to do so? Well, not going to unfold today, but these are the 3 directions I commit to, and I see the opportunity here. I invite all of you to think about this. The first one is this, you know, like when you propose new things, people come to you like, what do you know? you're just a programming monkey. You have no theories, okay? Well, that's not true. What I believe is that by looking at big data, you're actually more than ever higher opportunity to develop new theories that people never talk about or verify before, right? So in the first direction, the work so far, small, large, on-site, remote, we talk about the importance of interaction within teams. People don't talk about that, and people don't have data to talk about that before, right? The second direction, it's even greater. It's less about how people interact. It's about what's the nature of innovation. You know, there's a popular dominant theory of innovation in the past 50 decades in economics called recombinant growth theory, right? It's basically a metaphor of Lego. You have this, you have that, you put it together, and you have more things, together, it's more novel. This is just a stupid idea, right? You don't do science. Einstein didn't invent the relative theory that, okay, I have 3 things, 5 now, even better. How do I put this and this together? No, science doesn't start from that way. Science starts from a purpose, a frustration of the existing science not do good enough. It does not explain what you want to explain. And you have that purpose. So putting things together is not true, but it's not where science starts. It's not where science ends. You end up putting things together, right? So when you go to this complementary recombinant growth theory, they talk about the consequence because you know there are economists who never, you know. So when you go to the alternative, a missing piece here is how ideas substitute itself, right? How other people already have an idea, talk about things, and you're like, no, I don't want like that. I want a different idea, right? And here's the secret. There's no many big things in science. You think science is explaining every day, but think about the foundation of biology, computer science, or AI. There's no many different things. There's only one foundational things, or a few, right? In physics, it's about how does universe come from, right? In biology, is how do life reproduce itself? Where do we come from, right? All these foundational questions are very few, are very important, and generations of science, how it evolved is respond to these foundational questions again and again, use new theory that substitute the old one. It's not a complementary dynamic, it's a substitutive dynamic. Okay, so the last one is nowadays science. It's less about curiosity driven, right? You don't start the research like, I have 10 questions that I want to know. No, you start the questions, I have 10 students I need to supply, right? Now, where do I get money? Now, where do you get the money? Where the money is, right? There's a pile of money, right? When there's a COVID, there's a pile of money. How should respond to COVID? What is COVID, right? You are like a physicist, know nothing about COVID, but yeah, I can say something about COVID. So people will give you bills, and you can supply your students, right? That's how science is done today in a large amount. So we are shifting from important topics to urgent topics that society want to know. If you want to grow your lab, you got to work on something urgent. You got to respond to the call. You always say, we need a response. Response to whom? You don't respond to scientific curiosity if we positively assume that they can guide you to the important questions. You respond to what other people want so they can pay you, right? So underlying this kind of dynamic, science will be very different because money talks. Well, and then this raises the question, the money always talk in a way they can see the future or they just randomly talk. Right? Okay, so that's I didn't do this work by myself. This the remote work collaboration is done by Yiling, who is sitting right there, and she has done all the work. I just talk about that. And our great the collaborator, Carl Frey, a great economist in Harvard. Sorry, what I'm saying. I should steal the credit to US. That's for our own good. Right? Okay, so these are all the past existing collaborators that I learned a lot. Thank you.
You got just the content.
And how much time we have again?
The room is reserved until 1:30, so
and people will leave before.
yeah, likely, but we have plenty of time.
Yeah, please go ahead.
I wasn't sure if you addressed this, but when you had that graph of average age and average distance, how did you overcome some of the weird cases where it's like say like 5 people are really close together and one person is really far away, but they're not that involved, or you have like 4 or 5 students and like one super senior professor, and then you have to, like, if you find the average of that, wouldn't it seem a bit odd because like chances are it's the 4 or 5 students who are young doing most of the work?
Yeah, I really like that question, and actually, that question comes in our early stage of research too, right? If I understand you right, you're basically talking about different ways to measure distance. Right?
Yeah.
And they're not trivial. So that's why I like this question, because they are not trivial. If we measure the average, we assume everyone is the same, and the communication cost just increase by average. Right? And if we go to the scenario you just bring up, and we thought about a lot, it's about the max. There's a broken link of some other guy outside of everyone is here, but there's someone got missed, right? And that kind of maximum distance in the team kind of reduce the performance, right? So in our research, we try both, and that's one of the alternative we think about. It doesn't affect the results, but I like to think more and discuss more about what the nuance it determines in the future, because it's I think it's different of the maximum perspective and average perspective. Yeah, in this case, it doesn't change it just doesn't change the fundamental less innovative performance of the remote teams, no matter how we measure it. But I believe it changed things in the team. Yeah.
So did you ever try any like bin format instead of like a continuous variable for just the average age? Like have like 10 different types of like bins of like team setups, 2 really old people with 2 really far away people, and like these types of setups, and make it more of a discrete.
Yeah, it's mostly just a bin. Because everyone have a very specific, like, I'm 33 in Korea age, and he's 34. I didn't know that kind of difference. We try to bin that. Maybe the prioritize towards.
I'm wondering if it's really remote teams that is the problem, or if it is people that are more inclined to work on remote teams that are also more likely to do less disruptive work. So for example, or people or organizations, like for example, Carnegie Mellon has a humongous school of computer science, right? And so we are able to work on site more. And if I were to hypothesize that we do disruptive work, like there would be that correlation, right? Because we're just so big that we can do on-site work. But take somebody from Carnegie Mellon and have them work in a remote team and have them, perhaps they still do disruptive work. Like we have a professor here that did work in Africa with game theory and allocating park rangers to detect like where poachers are hunting wild animals, right? And that was a remote collaboration that I would say is really disruptive. So I'm wondering if you control for one person and say, is this person more disruptive or less disruptive or the same in remote work versus on-site work?
Yeah.
Would the results be different?
Yeah. So love this question. This is also like one of the key questions we try to think about in our research. There are 2 layers of this question. One, again, like the earlier question, one is, does it change the results, right? Maybe it's not interaction, maybe it's just individual difference, right? And then we control that, use the author fixed effect regression, so that we know that really it's just, even one for the same person, it will be different, right? So it's not about, we cannot blame or attribute to different people difference. Now, the second layer of your question is very intriguing. It's about, now we know it's not about different kind of scientists. It's about different contexts that scientists is operating. And our research, like this kind of design, it was used to study this context, right? So these are the same scientists, the same person. And exactly, I like your case, and actually I'll use it in future presentation, right? When that professor moved to remote, and maybe there are like different dynamic going on, open different or change the opportunity to conceive. Love that question. Please, James.
Yeah, I'm very curious about the nature of the collaboration between people you're working at the same location versus people working across locations. The people working at the same location tend to have more theoretical kind of contributions, right? And tend to have a two-way exchange of ideas, whereas remote teams, it tends to be one-way kind of broadcast. I'm wondering if developing theory just takes different kind of collaboration, much more intense, longer term, informal discussions and the kinds of things that you only get in the same site. Whereas other kinds, more technical, running a data set or creating a model or something could be done. Well, the reason I'm so curious about this is because it kind of suggests that richer tools, better tools, virtual reality, if you will, or something, right, might be able to kind of replicate the conditions that you need for sort of the deeper exchanges and maybe doing more theoretical work in distance.
We should write this down and send it to Zuckerberg, right? The meta universe. Can we do science in the Second Life? Yeah, I see that. And what we know is like a lot of people, some friends of friends just laid off, right? Anyway, so yeah, I like the direction this conversation is going. That's something it's so big. I'm terrified to bring it out in a presentation, but welcome all this conversation offline and emails. It's about distinguishing between taxic and the codified knowledge, right? So for some of you that less familiar with this idea is the taxic knowledge is like driving. You don't learn how to drive a car by looking at how other people drive a car, right? You got to practice it, right? And codified knowledge is like math, right? How to solve a equation. And you look at how people solve, you solve, right? Of course, it doesn't get you to the best mathematics in the world, but kind of getting there. So there are different kind of knowledge and a well-established hypothesis, but nobody actually, as far as I don't know, the measure is that kind of taxi knowledge flows very slowly, right? That's why we have student PhD mentorship, and that's why we need to meet each other. Because there's some invisible knowledge that taxi flow very slowly. And it's not like you can just dispute, send a paper and other people read the paper and just have next innovation, right? So I'll close it here, but my response to your question and my theory is that science innovation so far is still like handcraft. There's some kind of taxi knowledge involved in how to write a good paper, how to give a talk, how to create a new idea. But we don't know what that is. It's like driving. You got to drive together, you got to practice it and correct, practice and correct. You got to have someone side by side walk you through the whole process in 5 years of PhD to grow up. And you can't just do it in online university or virtual life. So that's my response. Yeah.
A couple of questions. The first one is, you lump these people into one team. You just call it a team and look at whether they're remote or not. But can there be more elaborate structures within? So you could have teams of teams, 2-team teams, or 3-team teams, and things like that. So do you have any thoughts about the finer structures that organize these teams?
Yeah, Yiling got a lot of say on this. We look at the GitHub data. We never mention it. It's kind of something we bury behind. No, we don't want to have it. No, so we look at the GitHub data, look at how people collaborate, teams within teams, across cities, within cities. It's very complicated. We haven't successfully come up with a new theory that fits in the narrative, but we definitely observe a lot of nuanced dynamics of teams within teams. A takeaway is structure within teams also matters. Yeah, go ahead.
Thanks for the talk. I was wondering, imagine we have 2 papers, A and B, and we measure the use your measurement, disruptiveness. And these 2 papers doesn't cite each other, but they share sort of, let's say for simplicity, same references. They are 2 different branches and both of them are disruptive. do you think if a third paper comes and built on top of these two, can be disruptive or not? The reason for this question is that if we can find something like this, maybe we can work on finding the areas that if we were combine, let's say for simplicity, combine paper A, B, A, B, C together, we can be innovative. We can create disruptive science.
Yeah, this is a never anticipate this question, but this somehow this question goes back to the fundamental dynamics in innovation about complement or substitutive, right? So what you are saying is, can we use complementary principle as a guiding principle of get science work, right? You have the most disruptive paper in physics, and you have the most disruptive in economics. What if we just put it together? Can we just eclipse or no? We just disrupt the field of both physics and economics. For now, I haven't saw anyone successfully done that. And or someone actually successfully done that, like some of my favorite scholars in Santa Fe Institute, right? That was really, go back to history, there was Nobel Prize Physics and Nobel Prize Economics to work on something new, right? But I don't think that's the motivation. I don't think that's how science works. That's not the first, like when this Nobel Prize Economics and Physics sit together in Santa Fe in the no people desert, they don't like, oh, we are the best in economics. You are the best in economic physics. We got to come out something the best. No, the first thing they did was they asked, what is the fundamental questions that will intrigue both physics and economics or all science? So every time you want to combine things, you don't just combine things. You go to a deeper thing that everyone can appreciate the contribution, right? So to me, it's always the reduce, the focus, the concentration, and the depth of idea that matters. And sometimes you come up with things that use different tools across interdisciplinary, and sometimes you don't. But it's a consequence. It's not how you start science. So that's my quick thought. Yeah. Yes, please.
So let's just say you're someone whose lab is completely remote.
That's me. I have only one student. Everyone is there.
So perfect.
I'm going to send it in my paper and they come over. You go.
So, okay, you're perfectly equipped to answer this question. And so short of joining the metaverse, do you have any recommendations for how you can optimize your experience?
Okay. So time to advertise a little event we are doing the Thanksgiving that Eileen is hosting. We are inviting all the lab members. They are not really lab members, they are just friends. Some are collaborating, some are not, but just invited over. And the motivation is because of that paper finding. I just realized this, no, this is not going to work. And there are tons of things, back to your question. I think this paper only covers some hopefully fundamental things between online and offline. And there are a lot of other things we didn't cover. Like we are easily, well, we can manage our debates better offline, right? Because we trust each other, we are in the same room, we allow this kind of debates. And debates are important in science, but you cannot debate in a remote work, right? In Zoom, you don't even, everyone want to try to say something and then they back off, right? They're so afraid of stepping on each other's feet. No meaningful debate is happening, right? So a lot of things, I believe, get back to the general big framework of lexic and codified knowledge. So yeah, I agree with you, and we should do more activities like this. So before Patrick, there was
earlier in the presentation, you mentioned this concept of the burden of knowledge. So the more knowledge exists, the more it's harder to learn all that knowledge. But at the same time, you've introduced this concept of disruptive science, where disruptive science invalidates the science that's come before, so you don't really need to know it because it's out of date and it isn't very useful. So have you, this is somewhat tangential to like teamwork, so I don't know if you've actually looked at this, but have you ever like noticed if there's sort of interactions between disruptive science and sort of that burden of knowledge?
You mean there seems to be an essential tension between more and very burdening knowledge versus disrupt?
Right, so if you, like, for example, I work in natural language processing. And previously the study there were recursive neural networks, RNNs, LSTMs, or variants on that. Then after the transformer architecture was released, LSTMs became not used very much because the transformer is just better. And in my natural language processing class, we like briefly touched on them. We didn't look at them very hard. We mostly focused on the new stuff. So that transformer definitely feels like a disruptive piece of science, and it's sort of invalidating previous things, but seems to have helped with the burden of knowledge in this case, because we don't have to learn some of the previous knowledge. But that's just one instance. I don't know if you had seen anything more broadly.
Yeah, you are talking about one of the most important theories in science, philosophy of science, by Bruno Latour. It's called a black box. Right? Science can be learnable. It's so learnable because it's a black box. Someone invent transformer, I just import that in my Python, and then I can just do that, do my new thing. Right? And you are exactly right. I really appreciate that your hunch going on here. That's going to be my goal in the next 10 years. So we hope I can live until then. So the fundamental thing here is there's an essential tension, right? Every generation, we all, okay, come on, let's be honest. We all know the metaphor, the ship pile of code, right? When you go to a company, there's a ship pile of code. And the best way is just contribute. You don't want to reinvent everything because that's going to screw your career, going to screw the company also. So science also developed in this way, right? Someone just come out this, someone come, and that's the burden metaphor. It's getting more and more complicated. You have a residual network, 100 layers. I'm going to do 300. Right? So this is his thing, right? All the way things. And now, think about this interesting dynamic. How Volkswagen was invented. Volkswagen didn't invent. I mean, I feel like I can say more, but I know I'm going to just play a professional that I don't have. Right? I just say something about. So if I get it right, Volkswagen was invented by reducing the complexity of previous generation of models, right? The neural network linguistic model has exist generations. They try all different kind of activation functions, very complicated. And what if we just make things simple, right? We have like simple addictive, just linear algorithm putting together, right? And because it's simple, so it's scaling up, right? And now, so if we think what if make things simpler, reduce the fundamental insight in that heuristic linguistic model. And after whatever, everyone tried to make it more complicated, right? Now, many layers, everything. So you see science goes in this way, right? Simple idea, more complicated but useful ideas, and then simple ideas, and then complicated, and then simple ideas, right? So if you look at this process, it's complementary because all these inventions are invented to complement that core insight, expanding. But from generation to generation, you have this kind of people. This is too much pile of shit. I'm not going to take this. I need to tear down everything and invent everything. And my lesson is don't try to be that one, because they're going to screw up everything. But if we are lucky to see someone do that job, that's kind of Einstein's job to Newton's job, just tear out everything and reduce. And you know how Einstein died. He died lonely, he didn't finish his work. He actually wanted to have a more simple theory of everything, right? Don't do that. But lucky someone is doing that, right? So you see that. That's my. Yeah, thank you. Thank you.
I'm just curious. So, what are the characteristics of the teams that score high on disruption? Remote teams that score high on disruption.
Yeah. Maybe they have more local component interaction. That's an intriguing question. I don't have an immediate answer.
Because if you can identify those, then you're getting kind of the best of both worlds. You get much more scaling. A lot of different team combinations can occur.
and they can also be disruptive at the same time.
Everyone would be happy.
Everyone.
Happy. Meta will be happy. We can still do Second Life, but with this parameter change. But I love that. I haven't. Yeah, it's a very interesting open question. One final from there, maybe.
So I think there are very interesting takes of what you're presenting, because I think what you're trying to say is, yes, remote teams might not be doing disruptive work, but maybe if we understand that, then we understand how we form our collaborations in the future.
Yeah.
So maybe like we can argue that if we want some collaboration to happen where the work is disrupted and somebody has to take some time off, come on a sabbatical or whatever to do the in-person work. But I think also that there is a value, like you did show the theoretical versus technical. I don't think it's necessarily only technical. I think it's going to give us insights on the practicality of the work. And I see this a lot, for example, in cybersecurity. We come up with those protocols, but then once you start deploy them in different countries that have different laws, or maybe no respect for privacy, like, wait a second, this is not the intention of this protocol. Let's go back to the drawing board and figure out how we can enhance privacy, or how we can come up with a scenario that takes care of that case study. So maybe with the remote work, when you start collaborating across continents, is where you see the practicality of things, and hopefully that the information you get from those is going to help the disruptive idea that's going to come into theory.
Exactly. So that's what we last 2 weeks ago I was in Vienna. They have a very nice Vienna Complexity Science Hub, and there's a huge amount of a big group, a community of regional economics. That's all what I care about. Basically, what you say is like the central question they have been discussing for decades, right? Why you cannot just move knowledge, right? The US is so great, and South American have so unequal benefits and knowledge in the world trading, right? Why you cannot just send someone out and we don't, so we can all make chips and send people to the moon instead of growing agricultural products. So, and you are saying a special kind that even for cybersecurity kind of burn into remote work technology, you can't even move it. You cannot just move a software. So you should speak to them, and guess what? not just bananas you cannot move. You cannot eat food. But yeah, I think that opens the huge conversation related to the taxi knowledge and codified knowledge here. One explanation to your observation is, it's just culture difference. Culture difference. But culture difference is so unsatisfying to a scientist, right? Everything is culture difference, and it stops. And then nothing you can do. You're like, okay, let's separate that. No, that's beyond culture difference. That's I really like the insight you try to draw upon here. That is, even for the most remote work things, like cybersecurity thing, to operate that, it still takes a lot of like local knowledge. Yeah. Right.
But here is what's puzzling to me. For
Yes,
example, especially during the pandemic, we did see less engagement with people working remotely, and we especially saw that on the K-12 education.
Yeah,
right?
yeah.
However, we do run a competition here at CMU. It's called Pico CTF. It's for solving CTF challenges around the world, and the winners are the prizes are given for the top teams in high school and middle school. And even before the pandemic, the top teams are remote. They never saw each other. They're not from the same school district. They're not sitting in the same room. We actually went into focus groups trying to study that, to see what is going on in there. We interviewed the top 5 teams because it does not make sense with all the research I'm looking at. And then I see those young kids winning. And I mean, there is I don't want to call it a culture, but they're coming from gaming. They hire each other from Discord. They actually interview each other to see, like, and choose who will get on the team. I interestingly found that some female players hide their gender. So, and they feel that this way they're not being judged. But I can't find an explanation. I'm still studying this problem. They cannot find an explanation why those teams are succeeding remotely, and the challenges are not dumbed down. If you're thinking, oh, they're cheating, no, the challenges are not dumbed down. They are actually they go up to a grad level. Like I have a couple of challenges where the grad students were like, how did they finish that in less than 2 weeks? We're still hitting our heads against the wall trying to figure that out. And I'm not sure what's
I
going on
cannot
there.
explain why some teams or even remote teams perform better in your competition, but I can explain how they can be worse in some other competition. I'm going to propose a competition of economic theories. Okay, so here's like every one of you, I mean, all you can just team up, try to come up the next generation best economic theory in the world. And I will bet my dollars that remote teams will fail. And so this back to the conversation of taxing and codified knowledge within science. Some science, I mean, in general, taxic knowledge cannot be moved, codified can be moved. But some fields and some knowledge are more taxic, it cannot be moved. And some are more codified. So think about, so in computer science is perhaps the most codified and therefore the most equal opportunity game. From time to time, you know this kind of the best algorithm in the history that you must know, the 10 algorithms. Now, I'll ask you like Dijkstra, right? All these like quick shorting, this algorithm, who invented it? Nobody, right? Or someone who feels like nobody, right? Linux, who invented Linux? Of course, Mr. Linux. But where does Linux graduate? Nobody knows, right? Okay, now back to the question, who got the Nobel Prize of Economics today, or next year, or last year, or 10 years ago? They always graduate from Harvard, from University of Chicago, and that's the observation, right? There's some kind of knowledge that's so networked, so in person, so clustered in this kind of rich club. It just cannot move them. And if you are not from there, then you screw. You just don't try Nobel Prize economics. Nobody will nominate you. But so that's the good news for CMU and for our community, right? It's some games are more fair than others. So yeah.
Maybe that generation learned how to live virtually better than us.
Let's have one last question.
Okay, just quick. It's nice. I think I'm wondering.
Sorry, I cannot help to final comment. But even for CMU people, even think about how CMU is so great. CMU is so great because as a campus have all these people, right? And if it's purely codified and you don't need in-person interaction, then we can just be an open university online. Then CMU will not perform better than the Coursera. And the fact that it's better, there's still some kind. So I love this discussion about to what extent it's codified. Sorry, I cannot stop.
Yes, I was wondering about the role of, you put it on your last slide, the role of money in the development of science, because one thing with high school kids and middle school kids, I don't care about eating. But when you are trying to get a PhD and then postdoc and then professor, I had to eat. And somebody has to pay that bill. And I mean, just for me, it was a shock to learn that US professors have to get money to get their vacations paid.
Well, you know, US people eat a lot.
Yeah. So I'm wondering if I'm in a remote team and I just have this weekly meeting, just 1 hour, right? Do I have time to make new ideas with just 1 hour, or better if I will be judged by my published record, then better something more broadcast, it will be paid better. So maybe also there is this underlying money that affects how.
Yeah, yes, go ahead.
Yeah, a comment on that.
I'll
I
just
think
do the
what you
host
make a
now.
good point, because in some international universities, they do not understand the theory. Like your contribution is theory, what am I going to do with that? Give me a tool.
Yeah,
And
yeah.
at CS, we see that.
Yeah.
And actually, I talk to colleagues and they tell me of how they lost funding opportunities. And I have a colleague who collaborated with another lab internationally, and they said they don't understand. They think of research as being a product.
Yeah.
And I had to explain to them that it doesn't happen this way. I'm like, and then they accuse the professor who she's in Berkeley is that she's lying and that she's stealing their money because she didn't give them a product. I'm like, I'm not gonna give you a product. I'm not a pharmaceutical company. But this is, people build on research, and she used examples with vaccines and with COVID, but she said that didn't, she ended up, her lab ended in debt because they didn't send the money for the collaboration for the other phases of the project. So, when she talked to a senior professor, he told her that this is very traditional when they do international collaborations, because there are institutions around the world that views research to be, you have to produce a piece of software, a drug, like some product that's tangible, and theory is like, so you're just sitting on a board and writing some formulas. How are we going to use this? And I actually gave a talk overseas. I was so excited. I just finished my PhD, and I gave him a research talk. And I usually get like very intellectual questions, but there was one time where I gave a talk, and people were like, "I have no idea how I'm going to use this," or "Is this just theory and nobody's going to use it?" And I'm like, "Okay, this is not the purpose of the talk," but it was an interesting question.
Yeah, and I should be there to defend your perspective, which I so relate with my international collaborators. And my pitch is, what is the product of science, right? Is it the papers or is it the people? Well, if you think the paper that carry discoveries or the software built upon that is the product, and people is a byproduct. And I totally understand what you're saying. Someone in Berkeley have this challenge. People like, you have spent $500,000 for 3 years and nothing delivered. But that's because you're looking at the papers, right? But if you look at the people they deliver, right? Look at if we revert the thinking, we think the next generation scientist is the product. And all these papers, small, big papers, term project, final project, they're just a byproduct. They're byproduct of training these people. Just don't look at that. Look at these. Look at how people will grow in the next generation. And that's the product that will make you win in the competition of world's talent.